Lesson 10C, we're talking about triangles today, specifically the sides and angles of the triangle. So you're finding missing angles and comparing the sides to the angles. And we're going to be classifying the different types of triangles. Write this down on your paper. In 6th grade, you talked about triangles a little bit, and hopefully you remember this. You can classify triangles by the sides and the angles. So let's talk about the angles first. There's 3 ways to name those triangles. This one's called acute because all 3 angles are less than 90. The second one's called a right triangle because there's a right angle in it, which is 90 degrees. And a third one is called obtuse triangle because there's an obtuse angle in it. Does this sound familiar? Yes. Okay, you can also classify triangles by its side lengths. The first one is called an equilateral triangle because all sides are equal length. The second one's called isosceles triangle. That's when 2 of the sides are equal. And a third one is just something else. And a third one is when all 3 are different lengths. That's called scalene. Does this sound familiar? Yes. Okay, then let's practice classifying triangles by both angles and sides. So the first one, we have a 6, and a 10. These 2 are the same. What is that triangle called? Isosceles. Now it's also asking you to classify by its angle. So looking at this angle, it looks like a pretty big angle. What's that called? So please write obtuse isosceles. We typically like writing the angle name first. So obtuse isosceles, write both of them. The second one is the one that has the 3 tick marks on it. That is signifying that all 3 sides are equal length. What is that one called? Equilateral. And if you look at the angles, they're all smaller than 90, so that is called acute. So you're writing acute equilateral. The third one has a right angle in it, so it's called a right triangle. And all 3 sides are different lengths. Which one is that called? Scalene. So you're writing right scalene. Number 4, we have 3 different side lengths. So again, that's called scalene. And looking at the angle here, which is a big angle, what is that called? It's an obtuse scalene triangle. Any questions about classification? Okay, turn your notes over. You are going to do 5, 6, 7, 8 on your own. Feel free to flip over to the fronts to help you spell or figure out what classification to use. Number 5, Trevor.
Obtuse scalene.
It is not obtuse. All 3 of those angles are small. Change your answer. Acute scalene. Very good. Number 6. Number 6. Moses. Very good. Acute isosceles. Right scalene. Very good. And number 8. Nicole? Right isosceles. Any questions about classification? All good now, right? Then let's move on. Sometimes you're going to be asked to do the same thing we just did, but without a picture. So I'm just going to tell you the lengths of the sides. 5 inches, 12 inches, and 13 inches. They're all different, so that is called what, Julius? Scalene. Now, I didn't say anything about angles, right? All 3 of those are side lengths, so you can't tell me if it's acute, obtuse, or right. So you're just going to write scalene. Okay. Number 2, look carefully. What kind of triangle is this one?
Isosceles.
Isosceles. There's 2 of them that are 3.05. And the third one? Equilateral. They're all the same. Equilateral. Okay. Now, in 6th grade, you talked about the 180-degree rule. We're going to use that to continue with what we've been doing, finding missing angles without a protractor. This 180-degree rule is really called the triangle sum theorem. And if you didn't learn this in 6th grade, don't worry about it. It's really easy. You'll learn it right now. What it means is that all three angles, all the degrees inside a triangle, when you add them up, it equals 180 degrees. So in this case, measure of angle A plus B plus C equals 180. So in this example, we have x degrees, 85 degrees, and 60 degrees. They have to equal all three of them together to equal 180. So x plus 85 plus 60 equals 180. Are you able to solve for x? Can you tell me what the missing angle would be? Good. X plus 145, subtract 145, you would get x equals 35. So the missing angle is 35 degrees because that's what would it have to be for all three of them to add up to 180 together. And you have to use an equation because, like I mentioned last week, your standard says that you have to. Now let me just show you a demo to prove to you that any triangle is going to end up being 180 degrees. So here's my triangle. I have angles in the corner, right? If I put all of those angles next to each other just to line them up, like if I slid this one down and push this one over, do you see how there makes a straight line here? That's 180 degrees. If I make that into a different triangle, let's make it slanted this way, make it really long. I'm going to do the same thing. I'm going to put all the corners together, and it still makes a straight line, 180 degrees here. Let's try making it into an equilateral triangle, like this. Same thing. Put them all together, it's still a straight line, 180 degrees. Okay, so it doesn't matter what the triangle looks like, it's still going to equal 180 degrees if you put all those corners together. Let's go back to our keynote then. And I just said you're using the equation because the standard says you have to practice it that way. So let's use equations. Number 1, find the missing angle using an equation. What is an equation I can write here? Using the triangle sum theorem, the 180-degree rule.
X plus 100 plus 35 equals 180.
Perfect. X plus 100 plus 35 equals 180. Go ahead and solve for x degrees. This will be 135. Subtract both sides. X equals 45. So the measure of angle x equals 45 degrees. I would like you to write your answer like this. Measure of the angle. Because this is not always going to be x there. In this particular problem, it just says x, but more often than not, it's not just x. So tell me that the measure of the angle is 45 degrees. All right, number 2, what is the equation we can set up here? Zach? Yes. Plus y. Very good. And then solve for y. Y equals 138. So the measure of angle y equals 138 degrees. Please rewrite it as the measure of angle y. The little m means measure. Alright, so far for 1 and 2, we just solved for x and y. But if you see on number 3, the angle degree is no longer just x. It's now an expression. So you have to solve for x, but then plug it back in. Okay, so you're setting it the same way. This angle plus that angle equals 180. So x plus 5 plus 100 plus 35 equals 180. And then when you solve for x, This would be 40. This is not degrees anymore. It doesn't say solve for x. It says find the missing angle. Does this angle say it's x degrees? Yes or no? No, it says x plus 5. So you have to plug it back in. X equals 40, but the measure of the angle is 45 degrees. This is why I wanted you to write your answer as measure of angle. Because x may not be the angle. X is just a number. Okay? Find x and then find the angle. Go ahead and do number 4. Y minus 8 plus 18 plus 24 equals 180. So after you solve for y, you should get 146. But that is not the number of degrees. You have to subtract 8 to get 138 degrees. Who got this one right? Okay, who put 146 degrees and then just stopped? That's good, good. Make sure you plug it back in to find the degree measurement. Okay, moving on. So again, going back to what we've been doing to find missing angles without a protractor, we are going to do the same thing with the sides and angles together. So we have a side length comparison here. I gave you a triangle where all 3 angles are labeled, but none of the sides are labeled. But you should be able to tell me which side is the shortest. So just by looking at it, which side looks like it's the shortest? The left side? Okay, just by looking at it, it looks like that's the shortest. And you would be right, but there is a mathematical way to prove that. If you look at these 3 degree measurements, comparing them, which one is the smallest angle? Right, that's the smallest angle. Now look at my arms. If I open my arms in an angle and I connect my hands like with a side to make it a triangle, that side's pretty short, right? If I open my arms wider, wouldn't that side be longer now? My hands are further apart. So doesn't it make sense that the smaller the angle, the shorter the side? The longer the side, the larger the angle, the longer the side? Does that make sense? So this side is the smallest angle, which would be opposite of the shortest side because it's open the smallest. So to connect the ends of that angle, it's going to be the shortest. Which angle is the biggest? Which angle is the biggest? How many degrees? 100 degrees. So that's open the biggest, which means to connect the ends of that angle, it would be the longest line. You see that? Let's practice that. In this picture, I want to find the shortest and the longest side. So I have to look at the angles. The smallest angle is going to be with the shortest side, right? But can we even tell which one is the smallest angle yet? No, why not? Right, there's one missing. So let's solve for the missing one first. I know that all 3 of them have to be 180 together, so I have to set up my equation. X plus 71 plus 63 equals 180. Solve for x. 71 plus 63 is 134. Subtract 134. X is 46. So I know now that the missing angle, measure of angle x, is 46 degrees. Now that we have all 3 angles, can you tell which one is the smallest angle? Which one is smallest? That one's the smallest. 46 is the smallest, which means it is opposite of the shortest side, which is side A. This is open the smallest, so this is the shortest side. Which side would be the longest? Why do you say C? You're correct. Right, it's opposite of the biggest angle. 71 is the biggest angle, so it's opposite of the longest side. Good? All right, let's do another one. Before we move on, let me explain. Right now, for this problem, we just named the sides by these lowercase letters, right? Now, usually, it's not labeled like that. Usually, we label it by the vertices of the triangle, and it looks more like this. Capital letters on the corners. Now you can't name them by ABC. You have to name them by the side lengths. So the smallest one again was 46, which means this side. So this would be called side BC. And then the longest one was here. This would be called side BA. Okay? I know that's not on your notes, but more often than not, you're going to see it labeled this way instead. Okay, let's do another one. I label the sides with lowercase letters, so you can go ahead and name the sides by the lowercase letters. Starting with the angles. We only have one that's labeled. It says 59 degrees. The other one has a box on my screen there. What does a box mean? How many degrees? 90. And I know I put it on your notes because I want you to see that the box means 90 degrees. It's a right angle. On your homework, if you see the box, that doesn't mean that you only have one angle. It means you have two of them. If you forget what that is, and you're going to forget later that you have another degree measurement to work with, go ahead and write 90 in so that you don't forget later. Okay? Can you solve for y? Do you know how? Good. Set up an equation. Y plus 59 plus 90 equals 180. 59 plus 90 is 149. Subtract it. And y equals the number 31. I want you to rewrite your answer as a measure of angle y equals 31 degrees. So now that we have all three angles, which one's the smallest angle? 31. 31's the smallest, so what's the shortest? Side B. Which one's the biggest angle?
Side A.
Biggest angle. How many degrees? 90 degrees is the biggest one. So what is the longest side? Side A. Okay, any questions about how to do this? Awesome. So now I'm going to flip it around and I'm going to give you the sides instead of the angles this time. And you should still be able to tell me the same relationship going on here. I have the longest side this time. Shortest and longest side. I want to know the smallest and biggest angle. So thinking backwards. Which one is the shortest? 5 is the shortest, which means that this angle here is the smallest. Which one's the longest? 16 is the longest, so that means that this one is going to be the biggest. Make sense? So it works backwards as well. Shortest side is opposite the smallest angle. The longest side is opposite the biggest angle. Yeah? Works both ways. Here's the one on your notes. I want to know the smallest and largest angle, so you have to look at the sides. Which one's the shortest side? It's 12. So which one is the smallest angle? Angle C. Angle C. Now, usually I let you write angle C, but I want you to get into the habit of naming it by the 3 letters. This is the angle we're looking at, and that is also called angle ACB or BCA. Okay, please name it with all 3 letters. C has to be the middle one because that's the vertex of the angle. Which one is the longest side? 17. So what is the biggest angle? B. Angle B is the biggest one, but I want you to name it with all 3 letters. What would that look like? This is angle ABC or CBA. Okay? Reading it in order. From A to the vertex, and then out the other end. Okay? Any questions about this? All right, number 2 is what you learned today. Ready? Share.
Okay.